Example 2. A thin strip of metal is bent into the shape of radius r. Find its center of mass. So this is my thin strip of material. It's bent into the shape r. Find its center of mass. So there's a two-dimensional problem, so we're going to have to find x center of mass and y center of mass. So here's another interesting problem, right? So here also we're going to use symmetry arguments to make our life a little bit simpler. So what it's saying is that we have this very thin piece of metal that's bent into a radius r, and it has a radius r, right? Okay, and it is saying that we have to find its center of mass, and it's calling this one as y and this one as x. Okay, we see that it is symmetric about the y-axis, but it is not symmetric about the x-axis, right? So how do we solve this problem? So since this is center of mass must be on the y-axis, so since center of mass, because of symmetry, must be on the y-axis, that means x center of mass has to equal 0. Well, that's one problem solved, right? But the system, so this is one, but the system is not symmetric about x-axis. So this means we have to find y center of mass. Now how do we find this? Well, what do we know? We know y center of mass is given by integration y dm, right? Okay, now how does that help me? So in this case, what I'm going to need is to choose a small dm, which is a small mass, and then I have to find a small d phi. Okay, so I'm just going to cheat a little bit. So I have a small dm, which is a mass radius, and I have a small angle d phi, right? With a radius r, that's consistent all the way around, okay? And I'm going to say that this angle right here is phi, and this is the small volume element of d phi, okay? So this small element, so this element dm is located at y equals r sine phi. So you guys can do a little bit of algebra, trig, and you can see that that is actually equal, that is indeed true. Okay? Now, we could use XYZ coordinates, but we are going to use the angular coordinates. It's going to make our lives very, very simple. So we are going to use angular coordinates, number 3. We're going to use angular coordinates, which means we're going to use r, theta, and phi, or spherical coordinates, however you want to call them. Okay, this dm is located at dy. So I also know that my total mass, I'm going to call this as capital M, and the total radius that it will go through, so the total angle that the thing goes through, so the total phi is pi, right? So from here to here, it can only go from 0 to pi. Now, what else can I say? So number 4 thing I can say is that the ratio of m, which is the total mass, to dm, okay, must be equal to the ratio of total angle, which is pi, to d phi. So the ratio of m to dm must be equal to the ratio of the total angle, which is pi, to d phi. Okay? So that means I can rewrite this as m over dm. It must equal pi d phi. Okay? So this expression I can rewrite as dm equals m d phi over pi. Right? Did I do that correctly? So I moved this over here, that over there, that over here, and that should work, right? So this was my original equation, right? I now have a y, and I now have a value for dm. Okay? Now I have to plug the numbers in. So I'm going to pick this expression from here, plug it into here, and I'm going to pick this expression from here and plug it into there. Okay? Which gives me y center of mass is now going to be equals to r sine theta m d. Oh, I called it, sorry, I called this phi. I'm so used to thetas. Phi d phi divided by pi. Okay? So from this expression, I'm just going to erase a little bit over here so that I have room to write. So y center of mass will be written as r m over pi integration sine of phi d phi. And the limits of integrations are going to go from 0 here to pi here, right? It goes all the way over from 0 to pi. Agreed? Okay, so I'm going to rewrite that here. 0 to pi. Okay? What is the integration of sine pi that you guys can do? Rm over pi. Sine is minus cosine. Phi goes from 0 to pi. You can solve it, and the answer comes out to be 2r over pi. Right? Oh, I forgot that this also has a 1 over m over here. So remember that. So this m, this expression has a 1 over m, so this m will get canceled. So we will not have m here. Right? And 2 over pi through over 3.145 is equals to 0.637r. So your y center of mass is going to be here. Your x center of mass is going to be here, and that is the solution to your problem.